Hi, and welcome to Storage Developer Conference 2021. I'm Richelle Ahlvers, Chair of the Scalable Storage Management TWG and the Storage Management Initiative. Today, we're going to talk a little bit about what's going on with SNIA Swordfish. And to kick that off, we'll start with an overview of Swordfish. So what is Swordfish? What's the hierarchy layout? What's the applicability to various types of infrastructure and what's going on there? Then we'll jump into looking at an example interaction. How can you work with a Swordfish implementation? We'll wrap up with this presentation talking about the Swordfish ecosystem and all of the infrastructure, documentation, tools, and programs that are in place to help you work with, develop, and promote the Swordfish specification. First, let's jump a little bit into some background. So what are Redfish and Swordfish, and why are we talking about them? Well, let's start with the basics. DMTF's Redfish specification is a REST-based specification to cover server, data center, and general fabric management. It contains a REST API with JSON payloads, and there's a choice of multiple different kinds of schema based on your development preferences that you can use to work with this. It's from CSDL to JSON to YAML. So then what's Swordfish on top of that? Swordfish extends that DMTF Redfish spec, leveraging the protocols, leveraging objects, leveraging services and definitions, and focuses on adding functionality for advanced storage management capabilities. This covers a lot of different use cases, from block, file, and object storage, external devices, as well as more comprehensive server attached or standalone systems. So Swordfish extends the traditional storage domain coverage to also include converged environments. This is where Redfish and Swordfish work together, helping to manage servers, storage, and the networks and fabrics. Swordfish also provides an option for implementation of a class of service-based interface. This covers comprehensive functionality and provides value add for those who want to implement a QoS-based interface to do so in a standard way. So that's the basics. What else are we working on? And what else is in Swordfish? One of the things we've been focusing on quite a bit over the last couple of years is adding support for NVMe and NVMe-OF devices. We've been working this through an alliance agreement and partnership with DMTF, bringing in Redfish components, and NVM Express, bringing in the expertise for the NVM devices and the ability to map our two ecosystems together. We've also been working on adding storage fabric management through another alliance partnership, this time with the OFA or Open Fabrics Alliance. We're working with DMTF and Swordfish to bring that base fabric management to cover the storage management use cases, and from an OFA perspective, to cover all of the different types of fabrics comprehensively. Let's talk a little bit about what Redfish and Swordfish look like now. So one of the key elements and the basic building blocks you'll hear referred to in Redfish and Swordfish is the service route. This is the fixed URI in our RESTful scheme to work from. This is at /redfish/v1. The basics of any kind of implementation within the Redfish ecosystem have some common components. First of all, there's a whole set of Redfish services. These include everything for account management, authentication, authorization, credential management, certificate management, all sorts of basic capabilities in that area. And these cover, the account service, the session service, the certificate service, as just a few of the examples there. There's also other basic service capabilities like log service, event service, and those are all common to both capabilities are common to both Redfish and Swordfish implementations. We move past that, we look at a standard split as well between a logical and a physical representation of components. The way this works is again common across the ecosystem. The physical representation is done through /chassis. And for the logical representation, you'll use the appropriate object here, whether that's storage, systems, fabrics, or whatever. This particular example shows how the basics and the components within the Swordfish hierarchy as well. So Swordfish will largely start in /redfish-v1/storage. You'll find a storage instance. This equates to basically each instance over here in the singletons. This is a collection, which is an array. Each instance in the singleton resource represents a storage subsystem. From that, you see a lot of the same components you would expect to see in any modeling technique. There are controllers and storage pools. Clearly, we want to get to the point where we're exposing volumes or file systems, but for scalability and manageability, those are always created out of a storage pool. And a storage pool is a collection of drives or memory or other pools or volumes, whatever the underlying capacity source is, that's what this is created from. And then you have from that volumes as one would expect. The chassis, what you'll see down here is, again, the physical representation. So that may be drives, that may be enclosures, that may be also the physical pairing and representation of advanced storage controllers. All of those kinds of capabilities would be built in and represented in the chassis interface. In addition, Swordfish adds the /registries interface specifically for the notion of adding a features registry. The features registry is a way for implementations to advertise the capabilities that they support in a very coarse-grained fashion for the clients to easily parse. I talked a little bit about some of the work we were doing with NVMe between DMTF, SNIA, and NVMe. And so just wanted to talk about that real briefly. There'll be a couple of other presentations that talk about this in more detail in this track as well. So if you're looking at NVMe, check those out. A couple of things to highlight here is that the work we've done to map NVMe uses exactly the same objects and models as traditional block storage. So here's just a great example. Using some of these NVMe specific terminology, you have where we have a storage object that equates to and maps directly to an NVMe subsystem. Where we have storage controllers, those map to NVMe controllers. Now, NVMe controllers are logical constructs rather than physical constructs, but the hierarchy continues to work exceptionally well here. We also have the notion of, the block storage components, which in NVMe parlance is called a namespace. That's just a volume. So you can see we've got the namespaces created out of the pools over here and referenced in this high-level collection just for ease of use. There's also usage in more advanced NVMe devices for storage pools, and those represent endurance groups and sets. And again, in the chassis space, we represent everything that's not directly in those specs, but needs to be modeled as part of the physical entity information. Other capabilities we're looking at adding and working on come in a couple of different spaces, but both use the fabrics, the Redfish fabrics hierarchy and definition to accomplish that. So this particular one shows two different things, one of which is just a general model for adding access rights for shared storage. And it also, just highlights a note that we've actually mapped all of this over to the NVMe OF use cases as well. The way this is structured is basically under fabrics, you use a triplet of objects. In this case, it's connections, endpoints, and zones. Endpoints represents the connection point, the abstraction of the connectivity to the targets and initiators themselves. Connections is where you describe the permissions for particular targets. So this may be, read write for namespace 1, and then you include some information in there that's also, can be done in just directly in connections, or if you're looking for a little bit more complex, you can bring in zones. But this basically says, yep, everybody can see this volume or this namespace, whichever, as read write, and includes their permissions. The other usage of the Redfish fabric hierarchy talks about modeling the connectivity. The previous one was really looking at modeling access rights. Now we're looking at modeling connectivity. So you still have those zones and endpoints that are used in a similar ways. Zones for grouping or exclusion, endpoints to reflect the initiators and targets and connection points, and then the switches that reflect the physical connectivity. Let's move ahead a little bit to actually interacting with Swordfish. What I'm going to talk through now is one of the basic features of a REST-based interface, where as a client, you don't need to actually study the specifications or even work your way through schema in order to be able to successfully navigate around and find out what's going on in the system. The use case we're going to look at here is just getting some basic volume capacity information. So there's a few things we'll need to do to work our way through that system. Basically, we start at that service root again. And from there, we'll find a storage object and then select and work our way down through that. And then find the volumes collection underneath that storage collection, and then find a volume and look at it. Seems pretty straightforward. It actually is. So let's take a little look in a little bit more detail. This purple line up here is the command that gets issued, the RESTful command that gets issued. This can be done through a web browser or through a REST client, a tool like curl, or programmatically through another client library system. So this is getting the service root. What we're looking for here is the storage instances. So here is this link represents a pointer to the storage collection. Let's go take a look at that. Basically, we take that URI and do a get across redfish/v1/storage now. And here we see that storage collection. And again, a collection is a set of like objects. So this is a storage collection. This indicates that there's 4 different storage instances in this system. We're going to pick this highlighted one in red, which is my device. So we'll do the same thing again, work our way down through, get the storage instance here, /redfish/v1/storage/my device, and then find in that payload the volumes collection and work our way down one further. I highlighted a little bit in the overview, but there are a few collections built into Swordfish for ease of use, and this /storage/volumes is one of them. As you can see here, this is a relatively short URL. When we go through that into the next one and look at the list, you can see these objects are scattered throughout the system. They're not directly in this in this collection. This is, again, just purely for ease of use. So we're going to go select this first one that, as from our original pictures and hierarchies, you could see there's storage and a storage pool. And then under that is the volumes that are allocated out of that pool. And go take a look at that first instance. We didn't have to navigate all the way down in the model to get there. This shortcut just takes us right to that object. So we do a get on that. And now we're looking at lots and lots of properties, but the ones we're specifically looking for here are the capacity information. So looking at allocated and consumed particularly, just for simple, how big is this thing and is it being used? That was it. We walked our way through the system. We've navigated down, and you could go back and you can continue to move your way around the system just to explore, or if you're looking for particular data that you think you have a good idea where it is, you can navigate around to find it without, again, looking at that spec or into the details of the schema. SNIA has developed a very large ecosystem working to enable industry interoperability around Swordfish and Redfish. There's a lot of resources available for you. If you go to SNIA.org/swordfish, you can find pointers to everything I'm going to be talking about here. This is really the key URI for you to think about in terms of being able to go and just find the information. The Swordfish resources include everything from specifications to multiple other documents we'll talk about in a minute, schema, registries, profile definitions, all sorts of information that's included there. There's also other supplemental and support tools like the online reference mockups at swordfishmockups.com and the practical guide. We also have a large set of open source tools helping to accelerate development, both on the SNIA side and the ones we can directly leverage from the Redfish side. For the SNIA side, that's github.com/SNIA. And on the Redfish tool side, that's github.com/DMTF. In addition to those, or to get more information, I should say, watch the tools presentation by Don Deal later in this sequence, expanding development of your Swordfish implementation using open source tools. Don will provide a comprehensive overview of the tools ecosystem. We also have the Swordfish Conformance Test Program that's been enabled to help validate implementations. This program can be used from, basically as you're first starting to develop the concepts and all the way through the development cycle up to and passing the CTP conformance for specific versions of Swordfish. It's a very, very useful set of tools to help keep your implementation consistent all the way through your development cycle. I'll talk a little bit more about what that looks like in the drive adoption of your products with the Swordfish Conformance Test Program presentation later. So we talked about all of these things that are available as part of the Swordfish ecosystem. But I wanted to talk a little bit more focus about what's actually in the Swordfish bundle. If you go to SNIA.org/swordfish, the main thing you see there is a bundle download, and it includes all 7 of these sets of functionality. So we'll of course start with the specification. This is again builds on top of the Redfish specification. We'll point back to that, but includes all of the Swordfish specific requirements and extensions. Then we have the schema bundle and registries bundle that covers all of the technical definition of the Swordfish functionality, as well as the profile bundle. And then we have 4 different guides that are very helpful for working your way through and helping to develop implementations, whether you're client side or server side. We have an API users guide. This provides a whole set of use cases around various functionality throughout the Swordfish ecosystem, showing examples and expected use. We have an error handling guide that does the same thing for errors and error message returns. Then when we get to the NVMe space, we have an extremely comprehensive document that's the Swordfish NVMe Model Overview and Mapping Guide. This document describes for multiple different NVMe device permutations, what properties you should be implementing in Redfish, in what objects and what properties, and also how those map directly to NVM Express specifications. The last but not least, we've just released the Swordfish Property Guide, which provides a listing of all of the properties used in the Swordfish schema. It's just a really nice listing to go see. If you're looking at a specific property, what's its definition? Where is it used? I hope you found this helpful so far. There is, again, more great content later in the track, but here's just a few pointers to remind you of where to go and what you can find in various locations. For SNIA Swordfish, we of course have the standards, specs, mockups, guides, all those documentation we just talked about at snia.org/swordfish. We also have an open forum that we share with Redfish at swordfishforum.com, where you can go ask questions about Redfish and Swordfish functionality, usage, etc. If you're interested in joining the TWG, go to snia.org/members and work your way through the process. If you're already a SNIA member, you can go to members.snia.org and just directly join the SSM TWG. If you're interested in promoting an education around storage management technologies, or Swordfish in particular, you can look to join the SNIA SNIA Storage Management Initiative, excuse me. For the other organizations that we partner with, we've also provided some great links for them. So we have the Redfish standards. You can go to redfish.dmtf.org or dmtf.org/standards/redfish to find the entire Redfish ecosystem pointers as well. For the Open Fabrics Alliance, we work primarily with the Open Fabrics Management Framework Working Group, or the OFMFWG. If you go to the OFA site, which is openfabrics.org, you can look for all of the related links for this work group. And then for NVM Express, all of the specifications and information can be found at nvmeexpress.org/developers. Thanks a lot for joining this session. Please take a minute to give us a 5-star rating and work your way on to the next presentations today. Thanks.